Lesson 1.6, Solving Problems Involving Rates of Change. In this lesson, what we're going to do is prove the existence of a maximum or minimum within a given function. Our first question is to show that the minimum value of y equals x squared plus 4x minus 21 happens when x equals negative 2. The important thing to note here is this is a quadratic function, right? We can factor this thing if we wanted to into x plus 7, x minus 3, right? This function then has zeros at x equals negative 7 and 3, and we can see from here that the axis of symmetry would be x equals negative 2. We know that that's a property of a quadratic, so we can assume that that's the case. We're not as much worried about the fact that it is a minimum, but I'm now going to show you how to prove that it is a minimum using instantaneous rates of change, all right? So our first step here is going to be to find the instantaneous rate of change at x equals negative 2. Right? We're doing this to confirm that it is a turning point. Confirm it is a turning point. This is an important first step because we need to ensure that the instantaneous rate of change is 0 here to make sure it actually is a turning point. Right? Once we find that, we are going to compare f of x values on either side. I'll show you what I mean by this when we get there. All right, so let's start by finding the instantaneous rate of change at negative 2. All right, so delta f over delta x is f at negative 1.999 minus f at negative 2 all over 0.001. This is the second method for finding instantaneous rate of change. Note that this looks like negative 1.999 because negative 2 is a negative number, right? So negative 1.999 is 0.001 more than negative 2. Okay, that's an important thing to note here. All right, so we have to find these values, right? Wrong marker here. So f at negative 1.999, we can use either the standard form or the factored form. Here I'm actually going to use the factored form. I think it's a little bit easier to calculate. That way you're not having to work with the squared. Right, so negative 1.999 plus 7, then negative 1.999 minus 3. If you want, you can simplify this a little bit, right? This is 5.001 times negative 4.999, right? That's a pretty logical simplification to do. And now we can calculate this thing. So 5.001 times negative 4.999. This gives you negative 24.999999. Good. We now have one value. Let's find f at negative 2 next. Again, we're just finding the instantaneous rate of change here. After the last lesson, this should be pretty standard. So this is negative 2 plus 7, then negative 2 minus 3, which is 5 times negative 5, which is negative 25. Right? Moving a little fast, but feel free to pause or slow down the video if you need more time to do these calculations. So now let's sub these back. So this is negative 24.999999 minus negative 25 all over 0.001. And when I do this calculation, I'm going to get 2.001. I'm going to get 0.001. And this is very close to 0. Right? We can assume that if we included more decimals on our 0.001, right, we'd probably get more 9s in this decimal place, which would just bring this result even closer to 0. Right? So even though we get 0.001, we can assume that this instantaneous rate of change is 0, which is what we wanted. That's good for us. All right? It is a turning point. That is what we were hoping to find. Now let's compare these f of x values. So we know that f at negative 1.999, negative 1.999, we know this has a greater value than f at negative 2, right? This is a bigger number than that. So in order to confirm it's a turning point, well, let's just find something on the other side of -2 to make sure it's above where f at -2 is, right? We want our function to kind of go like this, right? We're proving that it's a minimum. So we have the point here. We have the point here. Let's make sure that it rises above right after, okay? And what better way to do that than f at -2.001? So I'm going to go -2.001 times, plus 7, then -2.001 minus 3. Same thing as I did last time. This will actually be the opposite product, -4.999 times positive 5.001. And we know from the last calculation that these will be the exact same number, -24.99999. This is a larger number than -25. Right? So we have 2.001. Right? So since we have it like this, that f at -2 is smaller than both of the values beside it, we can confirm it is a minimum. And that is enough for us, okay? So again, we kind of saved some work there by doing the second method. Mind you, if you did the squeeze the interval method, you would find this value in this value, the two outside values, and then your third step would just be finding the middle, right? So that's an acceptable way to do it as well. But the idea is find the instantaneous rate of change at our point, and then use those test points to figure out whether it's a maximum or a minimum, all right? So that is how to do this application of rates of change. There will be another video in this lesson on how to do the equation of tangent lines, so make sure you watch that if you need it.